All right, we're going to go ahead and get started. Thank you very much, everyone, for joining me today, or joining us today. Excuse me. My name is Bob Walker. I am the head of the customer solutions team at Octopus Deploy, and joining me today is Alex Yates. And today we're going to be talking to you about getting started with database DevOps. Alex, how are you doing today?
I'm good, thanks. How are you?
Oh, I'm doing pretty good. Just a little bit of housekeeping before we get started. A link of the recording will be emailed to you. Typically, will be between 24 to 48 hours afterwards, but definitely before the weekend. And if you have any questions, if you're joining us on any of our streaming partners, such as Twitch or YouTube or Facebook, please use our community Slack and the webinar channel. And if you are joining us on Zoom today, please use the Q&A section inside of Zoom. The chat is a little hard for us to follow as to what questions are answered and when people ask them and everything like that. A little bit of an agenda. So Alex and I did some run-throughs, and no matter what we did, we couldn't fit in all the demos we wanted to do and talk about everything else that we wanted to do. So this is going to be very much a talking heads webinar. If you think of it as a college course, this is Getting Started with Database DevOps 101. It's very much a 101 class where what we're going to be doing is talking about some high level things such as what is DevOps, what is database DevOps, some techniques that you can use and adopt. We'll talk about change approval boards and gatekeepers, wrap it up with some further reading, and then move on to the Q&A. So there'll be about 5 to 10 minutes of Q&A at the end. Okay, so let's jump over to the discussion. So Alex, fun fact that most people don't know about, you're the one who introduced me to Octopus Deploy all those years ago.
Yes, I am. That was a really cool engagement for me as well. But yeah, I introduced you to it.
And it was actually, it was to solve database deployments, which was an interesting thing as well. Yeah.
So it's funny because at the time I worked at Redgate as a pre-sales engineer, and we were selling a competing product to Octopus Deploy. We'd actually licensed some Octopus Deploy source code, and we built our own product off the back of it called Deployment Manager. And it turns out Octopus Deploy just destroyed us. Paul was delivering much faster than we were, much better quality. But one of the suckers that I managed to sell the software to was you. And I was then faced with a really awkward position that I knew that Redgate had sold Deployment Manager. We're retiring Deployment Manager and we're going to start using Octopus Deploy instead. But then I had that job of telling all the customers, right, so I can't tell you publicly that we're retiring this product yet. But what I really think you should do is considering using Octopus Deploy instead of our product. And then I went in to try and help you use Octopus Deploy. And so, yeah, it was a really fun sort of engagement, much more consulting than I'd done before. But yeah, it had the added bonus that I got to meet you for the first time there, and I got to show you this new crazy tool called Octopus Deploy.
And what was interesting about that whole engagement is we were using, I think, techniques and having conversations that were very much DevOps like, but it wasn't DevOps. Like we weren't using that term DevOps throughout that entire engagement.
Yeah, I don't think we had the vocabulary yet. I mean, I know that the DevOps movement had started then, but it wasn't as big as it is now. And we were using words like continuous delivery and continuous integration and continuous. We spent a lot of time on that engagement, talking about the difference between CI, CD, and CD, and kind of where the organization that you were working for was going to fit on that scale and how you were going to do it. We didn't yet have the word DevOps. At least we didn't. The industry at large had started talking about it, but we hadn't started talking about it yet.
So you recently wrote an article around what is DevOps and why you don't think it's a good job title. But for those of us who haven't had a chance to read that article, what is a good TLDR definition of DevOps, since we're going to be talking about it quite a bit today?
Sure. So DevOps comes from this idea. It's a whole bunch of ideas that people realized at the same time. It had something to do with automated deployments. It had something to do with automated testing. It had something to do with infrastructure as code. It definitely had something to do with this wall of confusion problem between the developers and the operations folks who couldn't work very well together. So fundamentally, it's about working together in across different functional boundaries. So developers working with operations well together in a unified way. There are a lot of people that try and define it for themselves. So what I like to do is pull it back to the most widely recognized industry definitions as opposed to my own definition, because how many people have come up with their own definition of DevOps? The first one of those was created by John Willis and later extended by Jez Humble, which is CALMS: culture, automation, lean, measurements, sharing. There are a whole bunch of ideas to pack into there, but it's all focused around how quickly can we go from idea to production. We used to call that aha to kaching. How quickly can I put that idea into production, check that it's working, and then iterate and have my next idea. So that's kind of one idea of what DevOps means, and the implications of that are that we need to do better at working together, and we need to source control our stuff and put together automated deployment pipelines and stuff. The next one is the 3 Ways, which was by Gene Kim, who wrote the Phoenix Project and the Unicorn Project and co-wrote the DevOps Handbook and various others. So the 3 Ways, it kind of defines this journey that you're going to go on. The first way is system syncing. So it's that aha to ka-ching thing. It's how quickly can we optimize our business processes to make sure that we can get our stuff into production as quickly as possible. The next part is system sync, feedback loops. So it's about learning whether the thing in production is actually working, whether we're getting any errors, whether it's delivering on the business value. Software development is really expensive, right? So it'd be a real shame if we'd invested millions of dollars into building something only without even checking whether or not we'd achieved our objectives of building it in the first place. And put all that together, and if you can start getting to a point where we can iterate through that process really quickly, we end up with this culture of continuous experimentation and learning, which is the third way. The final way I like to define it is, the final best solution is anybody that's read Accelerate. Nicole Forsgren and Gene and Jez, who helped her write it, came up with these 4 key metrics, which are kind of the thing we should be aiming for, because these 4 technical metrics goals have a causal effect on IT performance as measured by, I can't remember off the top of my head, throughput, productivity, 1 or 2 other things, and that has a causal effect on business value as measured by market share, productivity, and revenue. And so those 4 metrics that we can work towards in IT are lead time, which is that aha to ka-ching thing. How quickly can I go from idea to production? Deployment frequency. Am I deploying many, many times a day, typically in much smaller deployments, or am I deploying once or twice a year in bigger, scarier, risky deployments? And then we've got change failure percentage, because there's no point releasing very often if you're failing all the time, and mean time to recovery. Note that's mean time to recovery, not mean time between failure. So it's the focus is more on stuff is going to go wrong. We have to acknowledge stuff is going to go wrong. The important thing is how we deal with stuff when it goes wrong, how quickly we can fix it, how we can minimize the effects of failures. That's much, much more important than this vain attempt to avoid stuff going wrong in the first place, because stuff is always going to go wrong. You can't stop that. So it's far better to manage those failures rather than to try and mitigate them. So that being the only thing that you're trying to do.
Yeah, absolutely. And, you mentioned like, hey, that whole aha to ka-ching moment, and, you want to get to production as fast as possible. But at the same time, that when you talk about databases, specifically like production level databases, there is some sort of risk involved with something like that. And it feels like a big part of this is, you need to de-risk that. And when we say database DevOps, what we're really doing is we're kind of saying, okay, there are some database specific problems that we need to focus on when we want to adopt these database DevOps techniques. Are Are there any other reasons why we kind of treat databases different than code, or do you kind of have like a strong opinion? Like, why do we keep on doing that?
So the main reason it's different is in the application of DevOps. Because I don't think that DevOps actually changes. Because if you think about all the things that I just said before, it's all about thinking about lead time, deployment frequency. It's thinking about safe deployments. It's thinking about how quickly can we iterate, how quickly can we innovate. All of that stuff is the same, and that's the core of what DevOps is. The technical practices are kind of the consequence of that DevOps mindset. So yes, the technical practices do change, but it's still fundamentally the same thing. So it's still DevOps. It's just taking that core understanding of what DevOps should be and applying it to databases as opposed to applying it to applications. In the world of web servers, we might like ideas like chaos engineering and stuff where we can just blow away web servers or entire regions and redeploy them from source code. That doesn't work so well with databases, or it kind of can do in some ways, but generally it doesn't work so well with databases because we've got data in our databases and we don't want to lose that data. And when we lose that data, we can't just trivially spin it up from source code because that data isn't in our source code. We're resorting to backups and all sorts of other things as downtime. That's one really big aspect of it. It's trying to figure out how we can do our deployments fast and safe regularly rather than big lead times without all of the bureaucracy that we've managed to, the DevOps movement has kind of generally managed to avoid for web server deployments now, but we still feel tangled up with it for databases. How can we cut through that bureaucracy? How can we focus on regular, safe database deployments? And there are a few obvious things that come up from that, and there are a few not quite so obvious things that come up from that.
So when you mention bureaucracy, I think of gatekeepers. I think about that article that you wrote about that. And I'm a developer by trade. Like I started back in 2004, and gatekeepers, bureaucracy, and the first thing that comes to mind with databases is DBAs. They're the ones that always wanted to ruin my fun because all I wanted to do was get my changes to production as fast as possible. And let's rock and roll. And the DBA is like, hey, hold up. Now, they have a unique mindset, and I imagine there's obviously a very legitimate reason why they have that mindset, and that was something that I had to learn when I started with database DevOps.
The really ironic thing is that engagement that you talked to us about at the beginning, where we met for the first time and where I introduced you to Octopus Deploy. It wasn't you that called me in; it was the DBA that called me in. It was the DBA that called me in because the DBA, he wasn't sold on continuous delivery, but he recognized the problems. So his problem was that he had, I can't remember exactly, but it was 12 or 14 or 15 different development teams.
Something like that.
Who were all sending changes to this same central database. So how many of us are dealing with an architecture where we've got a kind of core central database and 150 different applications and services are spun off that database? So this database is like a central point of failure. And if this database goes down, then like lights out, there's a big problem for the business. And so the DBA at your company, who's a good friend of mine now, and yours, I'm sure, he was responsible. He was ultimately responsible for this database. If it went down, the buck stopped with him. But he had 14 or 15 different teams that were constantly just sending changes at him, but they all had different processes. Some of them had their stuff in source control, some of them didn't. The ones that had it in source control were all using different tools and practices, and they all had their own repos. The ones that didn't have it in source control worked in different ways. Some of them would give him Jira tickets, some of them would email scripts. Like, it was a mess.
Bless you.
Pardon me. So as you can imagine, this poor DBA character, who generally DBAs are among the most experienced and most invested in members of your team. You don't get to be like a DBA is rarely your first job. You have to have a certain amount of experience and knowledge to do that role. But these highly qualified and highly experienced individuals end up basically being F5 kind of button clickers. All they're doing is trying to unpack all of these packages that have been put together by all of these different teams and run them. There's no sane, reliable process. Trying to keep track of whether that's been tested properly is impossible. He's given a script that might consist of 3 weeks worth of work for an entire dev team, and he's supposed to review it and test it and make sure he's happy with it in an insanely short amount of time. It just doesn't work for him. So yeah, in that instance, John, I think we can use his first name.
Yep.
John, he ended up being that bottleneck. He ended up being the button clicker. But ultimately, somebody needs to protect that data. Somebody needs to care about that data. And if the development teams are all doing their own thing in a non-unified way against a shared unified database, then ultimately we need to put in some sort of process to protect that database. So I think it worked really, really well when at the organization that we worked at together, we got all the development teams to kind of unify their process and start source controlling their stuff and automating it, because that allowed John to help deployments flow through the pipeline rather than to have an approach of standing in front of the database with a baseball bat, which he very much liked to do.
Yes, absolutely. Now, the one small clarification: it wasn't one database; it was one SQL server, and we had 80 different databases on it. But same core problem. We had 14 teams emailing him all these various different things. Hey, I need you to run this on station. Hey, I need you to run this in production. Here's a ticket. Here's all this other stuff. And he's like, this is just absolute madness. I think he called it the Wild West of database deployments.
And he liked calling it the Wild West.
Absolutely. And he was very much what I like to call a motivated buyer. And there are other gatekeepers or other individuals that you have those types of conversations with, such as QA or security or audit, where oftentimes they're brought in so far into the whole software development lifecycle. It's almost at the end. It's almost right when you go to production, then they're going to start doing these reviews. And so some of the techniques that we're going to be moving on to is how can we move some of these things away from production and closer to the actual development of the changes, closer to your dev environment, closer to your local, your computer and everything like that. And the first thing that I think you and I always just hammer on at first is get your database into source control. Now, that doesn't mean move your backup file into source control. What are we talking about when we mean hey, you want to really get that database into source control?
What are we putting into source control? Well, this gets on to, are we talking about this now, or the whole kind of state versus migration, the model versus migration approach?
Oh, we can absolutely talk about that now. Yeah.
So yeah, there are basically two ways to source control a database, and there are a whole bunch of different tooling, and the tooling's great, and there are a whole bunch of different ways that you can put it together. But essentially, there are two ways you can do it. You can either source control your migration scripts, v1 script, v2 script, v3 script, and then you run them in sequence. Or you can source control your kind of desired state, the model that you want to deploy. So I want these tables with these columns. And then when you deploy, you'll let software work out the scripts that you need to deploy it. So tools like SSDT, tools like Redgate typically fit into that kind of declarative way of working. Both sets are great, but fundamentally, yeah, what we're talking about is the scripts that define the schema of your database. We can go further than that. There are all sorts of other things that we want to be source controlling. Your security settings on your database per environment. We want to be the configuration of your SQL server. Anything that you can script should be going in source control. But most people, if people are approaching this from scratch, then it's a big there's a lot to do. So the first place we typically start is with the schema changes, because that's most often the thing that's most critical, because you've modified a column or something and then some subsequent services started breaking, and that's typically the thing that we start with, at least.
And so when I first started putting my database into source control, to be honest, the hardest part was figuring out what database to put into source control, or what version of the database to put into source control, because we had dev, test, staging, and production. And naturally the answer is it should be production, because that's the desired state. Well, yes, but there are changes in tests that are about to go to production. What about those changes as well? And on top of that, it was easy for me when I first started because we only had we had an application that hadn't gone to production. So whatever is in test, that's what goes into source control. When we did it for an application that had been around for, say, 10 years, we had all kinds of different cruft sitting inside of your test environment, your staging environment. We had QA only tables that existed in test, but not in staging or production. We had these backup tables that existed in production, but not in staging or dev. And you're like, which one do you recognize? And so we spent quite a bit of time actually resolving the deltas between all our different environments. And that is I think that's one of the kind of the first things that people kind of don't realize, that you need to do that first. Then you kind of have a good source, so to speak, that you can put into source control.
So I like to think about this from a lean perspective. So lean talks a lot about work in progress. It talks a lot about your inventory, which is the amount of changes that you're working on that haven't yet been delivered to production. All of that stuff that's hanging around in your dev or test environments, or maybe it's hanging around on a branch in source control that's still being worked on, or maybe it's a long running feature that you're working on alongside the rest of the work. All of that stuff is a bunch of investment. Think about all of the investment your business has made into building those things, and it's not yet, the business isn't yet getting a return on it. It's still got a cost associated with all of that work. All of the hours that are spent working on it, all of the infrastructure costs, everything to do with the cost of running that as a percentage of your IT budget, how much of that budget is still caught up in undelivered features. And one of the things that Lean teaches us is that we need to focus on getting that inventory, that work in progress, as small as possible. So when you initially come at this for the first time, what you might realize, you might have this wake up moment where you realize, wow, look at all of this investment that we've made in stuff that just isn't going anywhere. And then you've got all of the storage costs of that. Now, if this is a warehouse, we'll be talking about physical warehouses. If it's code, we're talking about all of this cruft that you've been talking about, all of this test code. Has this been deleted? Do we still need this stuff? I don't really know. All of those confusions, all of that delay that leads to mistakes, it leads to slow delivery, it leads to cautious behavior where we're not really sure if we can delete stuff. So absolutely, one of the goals of this is to reduce that down as much as we can. And when you first start, what you have to do, you start with production, because one of the objectives of this whole thing is to make source control your source of truth. Ideally, you want to be able to redeploy from source code with confidence, and it's the source code that is the truth, and production is a reflection of source code rather than the other way around. So what we need to do is we need to start with production, and you're right, working out those deltas, whether it be by a migration script approach, or whether it be by a state model based approach, whichever it is, and figure out how you can for each delta, you need to think, do we want this? Is it desirable? Is it intended to go to production? In which case, fantastic, ship it to production. Let's get that done as much as we can. And one thing that really helps is, before you do this, tell everybody, make it known that everybody in your organization, we're going to try and have a freeze on new work or something like that. And we're going to try and flush out all of this work in progress. We're going to try and complete stuff as much as we can, quite apart from whether or not we want to automate our deployments. That's a valuable thing to do anyway, periodically. Have a big flush of all your work in progress. Is it going anywhere? Are we going to do something with it? Great, let's push it to production. Are we calling quits on this? Great, let's delete it and get rid of it and simplify everything. Is this something that we still want? It's not ready to go yet. Okay, that's where you work out your delta and you stick it on a branch in source control or something with the intention of finishing it and merging it in as soon as you can. But it's a really important process, and also it's a really interesting process to go through, because you find out about all of these pieces of work that's going on that you had no idea were going on, and it highlights a bunch of inefficiencies and problems in your process quite often.
And one of the things I really like about source control as well is I now have that answer: who made the change, when that change was made, and then oftentimes why that change was made. Because if you have inside a source control, most organizations have some sort of rule where you're like, hey, we need to have a ticket number when you make a commit. Like, why did you make this commit? We need to know why. And if you don't have a ticket number, there needs to be a very legitimate reason why you made some sort of change like that. But the next step that you kind of take, and this is, I remember in our engagement that you had, you really hammered this point home once we did source control. You're like, you need to move from a shared development environment, shared test environment, into having every developer has their own local database that they can make changes on. And it's basically their own. Either they run it locally on their machine, or I wouldn't really recommend this where you have like a SQL server with a bunch of small databases for each individual developer. I think each developer should be running like SQL Server or Postgres or whatever on their own local machine. And that to me was a massive game changer once we started doing that, because it made a bunch of changes into how we worked, honestly. And yeah, I just think back to like, what were some of the reasons why you pushed that so hard?
So my favorite way to explain this, and I can't take credit for it, it was somebody who said it to me once before, and I was like, that's it. It was a developer I used to work with back in my Redgate days. He said, imagine if you were a .NET developer, and rather than working on your own local machine and using source control like most .NET developers do, imagine if we put all the source code on a file share and we let everybody hack away at it at the same time.
Mm-hmm.
Like, how on earth are you going to be able to manage that process? How often are you going to get that thing to compile when you're doing something at the same time as somebody else is doing something? How are you going to, in a sane way, separate out the work that you're doing from the work that somebody else is doing? How are you going to manage when you've tested your thing in isolation and want to merge it and push it to production and somebody else has finished their, like, how do you do that? And the answer is that you don't. You rely on every single person in the project to be finished at the same time, to have it building and working at the same time while they're all hacking away on the same database. You're relying on there not being anything else in the files at that moment in time that is for your next release or whatever. It just doesn't work. The other problem with this is that if you have a shared server, you get around the problem of having to source control your server config to a certain extent, because if you've only got 2 or 3 servers, you've probably not really got to the point where you feel like it's important to source control them, because there's only a couple of them. You can probably manage that. If you're going to the point where a typical workflow goes along the lines of, I pick up this ticket off Jira or Trello or off the backlog or whatever it is, I pick up a piece of work, I spin up a local dev database, I do my work, I make my changes, I check them into source control, and then I blow away my dev environment, ready to respawn it next time I want a dev environment. Once you get to that point, it's necessitated that you've automated the provisioning of that database environment and that you can do it quickly, easily from source control on demand. And I'll tell you what, once you can do that in the dev domain quickly and easily, it means that you've already learned a bunch of the skills and a bunch of the tech, and you've got that experience, so that when you start thinking about how you're going to do this for production, it's a lot easier and a lot more straightforward. It also helps you to get around a bunch of it works on my machine type problems. Ironically, because it feels like you're going to run into them when everybody's working on their own machine. But actually, when you get to the point that you're automating the provisioning of environments for developers, I once had an issue where a developer had set up their own developer environment, but they used a different separate
collation.
Collation, yeah. They used a different collation to the one that everybody else uses. Just a subtle difference that they never noticed when they were doing development work. When they committed to source control, they source controlled their collation for a particular table versus a collation that somebody else was using. And obviously that ran into problems when we deployed it down the line. So when you install an environment, how many people consistently use the same settings? Or if you've got a team of 100 people, what are the chances that they're all going to use the same settings when they install SQL Server for the first time? They're just not going to do it. Some of them will put, some of them will set the max memory at a different level. Some of them will put the default locations of various files in a different place. Like, everybody's going to do it slightly differently. And that's going to create, it works on my machine problems. When we start automating this process, whether it be by Docker files. You wrote a really good blog post, which I've used recently, which is all about the automation of the installation of SQL Server.
Mm-hmm.
Yeah, however you do it, it's a huge benefit, and it has huge consequences to the repeatability and safety of your deployment pipelines.
And the thing I liked about it the most, honestly, was I remember so many different times that we would make a change, because at the time we had a shared model where, we make a change in dev and then almost immediately we turn around and make that change in test. And then we're pointing all our source code to our test environment, because that's the way we roll, apparently. And what was happening was things would start breaking because only one developer had the necessary change, like the source code change for that store procedure change, for that new table, for whatever the case may be. And everything else, like that would tangentially touch that table, would just start breaking. And it would just drive everyone absolutely batty, especially like our QA people or our business owners, and they're trying to test and they're trying to verify it, and they're going, why is test so flaky? It's, our test environment, like the developers just don't know what they're doing. It's like, no, it's just the way that we were working. Now with a local database, when I check in my code changes, I can check in my database changes roughly at the same time and have that be part of a pull request and merge everything in like kind of one bit.
Was it it might have been that visit that we were talking about earlier. It might have been a different visit I went on. Was it there that somebody managed to accidentally delete all the users from the dev database and lock like the entire dev function out of the dev environment for
that wasn't us, thankfully.
Okay, no. There was an environment. There was a place I went where they had 100 or so engineers in the IT team, and they had a dev and a test and a production environment. Somebody had managed to delete all of the users from the dev database, which weren't under source control. So it's like, I didn't have a record of who had users on the dev database. It's the dev database. It's a Wild West. Who cares? But the real kicker is that the DBAs, who were the only people that could come and fix it, at the same time were dealing with a critical production issue, which meant that they didn't have the time to come and look at dev for several days, which meant that you had a floor full of like 60 developers twiddling their thumbs because they couldn't do any work because their dev database was broken and the DBAs were busy solving fires in production. Crazy. You want to get away from that single point of failure. And how often is that single point of failure the database? Obviously in production, but also if you have a shared development environment in dev as well, it's hugely inefficient.
Yeah. And that's why I love that whole local database development. And I'm going to go back to that. So I'm going to move on to this pull request concept, because I think once you start doing local database development and you have stuff in source control, now you can do pull requests, and that opens up all kinds of different automation opportunities. So you could do something like, as part of my build, when I kick off a pull request, I'm going to go ahead and spin up an empty database. I'm going to run all my scripts. I'm going to make sure everything works correctly. Not only that, I'm also going to have another human being take a look at it. So before, what was usually happening in our case between test and staging, when it was time to promote to staging, that's when the actual quote unquote approval would occur. Now that approval is occurring before we even merge into our main branch, which that is just so much more powerful.
I was about to come back to the approval thing as well, because one of the truly damaging things about change approval boards and the approval process is when that happens late in the development process, by which point it's kind of already too late to implement any of the feedback that they're giving you without going into another whole 2-week rotation or something.
Train has left the station at that point, pretty much.
Exactly. And when that change approval board, by that point, because it's so late in the process, is listed with this Excel spreadsheet full of hundreds and hundreds and hundreds of items of things that want to change, it just resorts into a tick box exercise. Is there going to be downtime associated with this? Have you done your testing? Can I see the test file? It's not useful. When having that negotiation about can we get around the change approval board, the mistake that a lot of people make on the dev side is they tend to say things like, look, this is hugely inefficient. You're slowing me down. You're a problem for me. What works an awful lot better is offering an olive branch, is coming at it with a positive mindset, saying, look, how can I help you to make these change approval board meetings run more smoothly? How can I help you to pre-approve a whole bunch of stuff so that we don't need to cover it in this meeting. For example, what are the things that you want to see tested? Great. Can I do that as part of my pull request process? Can I automate that as part of my pull request process so that when I come to that line in the Excel spreadsheet, could I even automate that, the population of that spreadsheet with the link to the PR with all of the details about these tests have passed? Stuff like that. And how can we automate all of those green ticks in advance? At what point can we do enough automated test and verification that your entire Excel spreadsheet is ticked, and we can, which means that I'm free to push my stuff in production, and also you have more time in your change approval board meeting to discuss the actual important things, rather than wasting your time with the long tail of minor deployment updates that have already been through the entire testing process anyway. But that process only works when you have a proper automated testing process as part of your kind of CI, pull request, whatever process. And yeah, so for me, when developers get annoyed of these change approval boards slowing them down without actually trying to take on the responsibility of automating that testing out the way, it's kind of putting the cart before the horse. The correct way to solve this is to automate as much of the testing away as you can. Ask the change approval board what you can do to help them to pre-approve stuff as quickly and easily, and try to automate it. And source control and automated deployment and automated testing is great for this, because you've got audit logs, you've got all of that stuff in there. And it just, that's how you can turn it into a positive process. It can enable the frequent release of small, safe changes, as opposed to the infrequent release of big, scary changes.
Yeah. And, we're kind of touching on automated deployments a little bit, but to be honest, there's actually a lot of things you kind of have to get out of the way before you even start talking about automating. Like we talked about source control, local database development. You need to have a CI server, building your databases, running all these necessary tests. And then you actually get into the whole automation of, I'm actually going to do my deployments to my test environment, my staging environment, my production environment. And even in there, you can have different types of updates. Different types of automation checks. So you can say, hey, when I go to production, and if I see some certain keywords like cursor magically pop up that I never saw anywhere else, then I need to have another human being take a look at this. Like I need to have someone say, oh, what in the world is going on? How did this fail all these other checks? But hopefully never get to that point. Hopefully by the time it gets to production, all of those changes have been tested and verified and moved through there, because you have this known state almost that you're moving, you have this known package that you're moving through your environments.
I absolutely love that. It's such a simple thing that you can do, but with all of your deployment scripts, just scan for words like cursor or drop. And if those words exist in the script, then call them out. And okay, there'll be some people that say their store procedures all say drop and create or whatever, but like just taking that idea and running with it, kind of what are the common things that people look out for? Because a lot of the time when folks are doing a review of a deployment, they won't admit it, but what they're actually doing is just running through a mental checklist in their head. It's actually quite formulaic what they're doing. And there are certain things that they're looking at that are going to jump out at them. So one of the best things you can do is start by talking to the people that do that approval at the moment and say, right, what is your process? Let's do one together. And can you just kind of write down at each point what your thought process is? What are you actually doing? What are you checking for? And once you've figured out what those things are, probably a lot of it you'll be able to automate. Now you're going to need the person's help that's doing the review, because quite often that's a DBA, and the DBA has a different set of skills and experience to the developer. And so the developer will say, hey, why can't I use a cursor? And the DBA will say, well, this is why you can't use a cursor, and this is why it's really important. But having that conversation, making it a DevOps thing where developers and operations, or developers and DBAs, are working together on this thing, making sure that the gatekeeper, DBA, ops person's feedback is included, maybe even get them to write the script for you, getting them involved. That's a really productive way that you can make your deployments faster and safer at the same time, and then allow the DBA or whoever it is to focus on drilling deeper and constantly improving this process.
The What's really also cool about this is once you've kind of done this, then I think it opens yourself up to a bunch of other options. And one of the techniques that we're going to talk about next, which is the expand and contract model, because now you can start doing these other types of experimentation, not necessarily experimentation, but you can start making these smaller changes that are much less risky. And maybe you have these conversations around deploying in the middle of the day. So when I say expand contract, Alex, what's like a good TLDR definition of that?
Okay, so expand contract is a way of making deployments safe and also achieving zero downtime. So one of the reasons why deployments of databases is often so horrible is because it so often needs to be coordinated with other dependent systems, and you need to make sure you're running the correct version of the database with the correct version of the application and all the other downstream systems. And so really to do this properly, we need to take the system offline for a period of time, update all the various different bits, and then turn it back on again. And then the business says, well, you can't do that during business hours. So you end up doing it at 2 a.m. on a Sunday night when you're not the best version of yourself. And the developers that wrote the code are sleeping soundly in their bed. So if anything goes wrong, you don't really know who to call. It's just, I can't believe that such a bad process has become the norm for deploying the most critical part of the system. So a far better way of doing it is figuring out how we can do these changes during business hours when you're the best version of yourself in a safe way, and expand contract helps with that. So the basic premise is, let's use the example of a table refactoring. So we'll rename a column from full name to separate first name, last name columns. That's the sort of change that most of us can probably understand what we're doing there. We're taking the full name column. The first thing we need to do is create our two new columns. We need to copy the data across, splitting it in the middle. And then after a period of time, we need to delete the old one. So the expand part of the process is where we create the two new columns. And over time, while the system is running, we trickle across the existing data from the full name into the first name, last name columns. That's something we can do a couple of rows at a time over whatever period of time is necessary to make sure that we're not hammering the performance of our server. And that can all happen during business hours because there's nothing very dangerous about that part. It's creating a new column and moving some stuff across. That's fairly easy. The next thing that we're going to do is ideal if we're using stored procedures or something to do all the inserts and updates. We can change our stored procedure to make sure it's deploying to both places. And if you're deploying directly from the applications, you need to go and update all the applications. But this is something that can happen again during business hours, because these are changes, just changing it from writing to one place to changing it to writing to both places. Minuscule performance impact each time you run that query, but not a dangerous change. So we've expanded it. We now have a level or two of backward compatibility. Then at some point, we deploy the applications to turn off the old functionality. So everything is just using the new columns. And once we've been running that for a period of time, we're then free to do the cleanup. And it is really important to do the cleanup, because otherwise you end up with all sorts of columns all over the database that aren't being used, and you're not sure if you can do anything with them. So it is important to make sure you do that cleanup. Think of it as tech debt that you need to pay back. But this entire process is a way that we can perform that update during business hours while everybody's looking at the system. When we come to do that delete, we don't just delete it straight out. What we actually do is we rename it first of all to column underscore to be deleted on and a date to make sure it doesn't just hang around all the time. And if possible, you keep tracking reads and things from that column. And I mean, hopefully there won't be any reads from that column. If anybody is now calling a column called to delete, then they probably need to have a serious talking to. But so that is the expand contract model, and it allows us to do safe, because not one of those steps at any point in that process was particularly dangerous, and each step was fairly easy to roll back fairly quickly without significant consequences, which is one of the other issues with database deployments. It's rollbacks. If you screw up the data, it's pretty hard to roll that back. So each step of this process was quick to perform, could be done during business hours, and easy to roll back. It does mean that the entire deployment process is more complicated. It requires a little bit more rigor. We need to think about how we manage dependencies. So this stuff isn't free. This stuff is quite hard, and there's no such thing as a free lunch. But this is a fundamentally better way of approaching it than the old way that we used to manage database deployments, which is fundamentally risky and broken.
And one of the things I like about even thinking about that concept of a stored procedure is you can even make that stored procedure backwards compatible as well. So you could say, I'm going to have a first name and I'm going to have a last name parameter. They're going to have a default of null. And if I see null, then I'm going to look at whatever came in on the full name, and I'm going to do the necessary bits and pieces. Or you might have some other different types of logic inside of there that basically says, okay, if the first name, last name's already been populated, and all this other stuff. But what's really nice about that is you've made those small changes over time, and you're not like, oh my gosh, I have to make sure I'm also passing in first name, last name into these stored procedures via the code. Like you can even update even small bits and pieces. I think one of the other, sorry, go ahead.
I can say absolutely. It builds on that idea of small failures should cause small problems rather than causing global outages. So we should be trying to code defensively where we can. We should be trying to handle any database read errors gracefully and raising sensible warnings in our telemetry so that we can say, look, something's going on here, we should look at it. But it also talks to, and this is something we've not really talked about yet, loosely coupled systems, and whether you want to go full microservices or not. I'm aware that microservices is a buzzword that is quite divisive, but generally creating more loosely coupled systems is not that controversial. We want to avoid that big monolithic database in the middle of everything and trying to break stuff out as much as we can, because what that means is when we do have issues, they're smaller, they only have smaller effects. We don't end up causing global outages, and coding defensively, and wrapping all of your tables behind stored procedures or views or something is a really good way to manage that.
And I think the other thing I don't know if it's as a parent, but as I was listening to it, was each of those steps that we just described, that's a separate deployment. So adding those two columns and maybe adding the stored procedure, that's a deployment. And then updating the code, that could be another deployment. And then going back through and renaming the column to make sure that no one else is using it, that's another deployment. And then the final deployment is actually removing the column completely. So like you said, each time that you're doing it, it's not a massive change. If something goes wrong when you add two new columns into a table, you probably have a lot of questions to answer. But in general, like when you delete the column, at that point, the code has already been running, and you had that column that's already been named to delete on a specific date. Like you said, if anything's referencing that when you delete that column, again, you have a lot of questions. Some people have some questions to answer. But I also think back to, like, this also takes a great deal of discipline across the entire development team. Everyone has to be on board with it, and everyone has to follow it. And that's also why you want to have those pull request processes in place, so that can also be enforced.
I've seen a couple of different ways in Octopus Deploy managing this as well. So I've seen some people who've got a separate environment. So you've got the expand environment and the contract environment, so that with different processes, and the pull request requires that you've got both the expand script and the contract script in there as well. And once it goes to the expand environment, after a period of time, it automatically goes to the next one, or you can pull reports on which features are in deployment, because you've done the expand part but not the contract part. I've also seen people have separate projects for the contract bit, and kind of one triggers the other one, either automated or not, or you can pull reports and you can do it manually when you want to. There are various different ways of doing it, but I think one of the things that is important is that you keep track, and you don't forget to do the contract part. So whatever your process looks like, you need to make sure that you do actually close it off afterwards. Because how frustrating is it to have a database with 150 columns called to delete in them? And once they hang around for a while, you end up seeing kind of dependent systems who are calling the to delete columns because they prefer the way that it's formatted the old way, not the new way, and stuff like that. Or the quick way to fix it when they see that their application is broken is, rather than to hunt for the new schema, they just rename the column in their calls to the to delete part, which I've seen done before. As crazy as it sounds, this stuff happens because people are like, I'll fix it tomorrow properly, but right now it's midnight and stuff's broken, so I'll fix it the quick way now, and I'll come back and fix it properly tomorrow. But of course you don't do it tomorrow because something else is on fire tomorrow, and so it happens, as crazy as it sounds.
So I think we're going to move on beyond this, and before we move on to the Q&A section, we talked a little bit about approval boards, so I'm not going to really discuss that any much more. The DevOps reading list article that you wrote, Alex, I really enjoy this. Yeah, it's this whole choose your own adventure as to, hey, if you're really interested in DevOps and some of the topics we've been talking about, you have a really great way of saying, start here, move on to this book, move on to this book, move on to this book. In addition, we'll have links to that in the follow-up email, as well as links to various blog posts that Alex has written, I've written, and all that other stuff to help you get started with this, because this was only 50 minutes. And honestly, every technique we just talked about, source control, automation, local database development, expand, contract, that could be a webinar unto itself, or a series of webinars unto itself. So we barely have scratched the surface on something like this.
Yeah, we've been almost criminally high level as we've been talking about like such big concepts and spending about 2 minutes talking about each one.
Well, it's the 101 version of this particular topic. So I believe Mark is the one who has been curating some questions for us. So Mark, do you have any questions? Maybe.
Hello. Yes, I do. Can you hear me okay?
Yep, can hear you perfectly.
Perfect. 1 second. So yeah, we've got quite a few questions. I'm not sure how many we'll get through. Let me just have a look for you. So the first one is, would you put the database code in a different repo to the application code? And why not use the promotion model so all environments live in source control?
I have my opinion on
a question that always comes up.
Yeah, my preference is the database source control is part of the same Git repo as your C# code. That's my personal opinion. I found that it's worked the best. I know other people have other opinions around that.
I think it depends on architecture and dependencies. I'm a consultant, right? So everything depends. Can you build the thing independently or not? So I agree that in general, you want to have the application code and the database code nice and close together, but we're using Git because it's the only sane source control system to use in 2021. And Git doesn't like really, really big monolithic repos with everything in there. And so if you've got that horrible kind of big central database and 1,000,001 applications building off it, then are you going to put your entire organization's code base in a single repo? No, you're not. So in that scenario where the database ends up getting managed as its own separate project with its own separate team around it, there it's probably its own thing, which causes all sorts of dependency problems, but those aren't source control problems, those are broader architectural problems. Ideally, I agree with Bob. If you have got to a nice place where you're dealing with much smaller services, each with their own database, then yeah, application database side by side. But that's a big assumption that we're making, that everybody is already working that way, because most people aren't.
Yeah. And I think when you as you move on to the expand and contract model, it might make a lot of sense to have your database be pulled out of your the same Git repo, and have it be a separate one, so that, because really the database should be deploying on a different cadence than your source code at that point.
Yeah, that was the other big question, which I forgot to mention before, is what is your deployment cadence? If you deploy on the same cadence, it should be in the same repo. If you deploy on a separate cadence, then it's probably a separate repo.
Cool. All right, Mark.
So the next one, it's a favorite for Octopus, is around multi-tenancy. So our application is multi-tenanted, but our database is not. how best and efficiently can we roll out database schema changes across all our tenants, their databases, considering we have more than 300 of them in Azure SQL? And just added a caveat saying, please don't judge me not to have multi-tenant databases.
I've run across this myself. I worked at a place right before Octopus Deploy, where I think we had 80 different customer databases. They all had to be on the same schema because we had one website, and basically the code was changing the connection string on the fly based on whoever logged in. So like if I logged in as customer A, I'd get customer A's database. But if I logged in as customer B, I get customer B's database. And so there are some techniques that you can do within Octopus Deploy at that point, but essentially it's one deployment of that database. It's basically like you treat that single data, it's treated as almost a single database deployment. If you have a separate database and you have a separate code base, like basically everyone has their own infrastructure, then you could use something like where it's multi-tenancy. But I'll include a link to there's a different article. I wrote this on my personal website around this whole conversation. Alex, I don't know if you have any other thoughts around that as well.
Well, the expand contract model works really, really well for situations exactly like that one.
Yep.
You could have, even if it was all part of the same deployment pipeline, you could have one environment be the expand database bit, the next environment being the multi-tenant deployment that goes to all of your different applications. And once the code has been deployed to all of the different applications, once it's been deployed to all the different tenants, I should say, then you can do the contract bit afterwards. So that's one way that works.
Yeah, it is a complex problem to solve once you introduce multi-tenancy. And it also, back to Alex's point, it depends really on your architecture as well. So
cool. So I think we've probably got time maybe just for one more question, if I may.
Yep.
So how do you deal with data in these databases per developer environments? We work in the field with a lot of personally identifiable information, and have a big enough database generating data set across it would be reasonably complex. This person said when factoring contractors that they have kind of SOC 2 compliance issues, they can't have access to that data. So they struggle answering the question how to get to manage and create those developer databases.
So the first thing I'd say there is, what are you doing at the moment? Because if you have PII, is it really okay for your contractors to be able to read it from your dev database, even if it's a shared database? So I feel like a lot of these data privacy questions, which are absolutely critically important, they're another whole session in their own right about masking data. Hopefully you already have processes to mask your data. You've got a dictionary of a data dictionary or a data map of kind of where all the PII data is, and you've got masking routines in place to make sure that your data is masked in dev. That's obviously important. Other than that, so basically that's how we need to make sure that any data that we use in dev, whether it's in a shared dev database or whether it's on local dev machines, is masked. The next thing that you can do if you don't have that, which most people don't have that, is empty databases or databases with case studies put in there, or databases where you've just stripped out all the PII stuff and put in a few use cases. I know it's hard, it's not easy, but they're the sorts of things that we can do.
One place that I worked at, the way that we solved that was we actually wrote it was almost like a mini cloner. So this was for a loan origination system. And so QA, they would enter in a bunch of different test loans into the test database. And I'd want to pull one of those down into my local database to test with. And so it was a small program that we ended up writing that I think it actually used Entity Framework that basically walked the tree and basically said, all right, this is the record, this is the parent record I want, parent ID. And then it walked the tree and it actually copied in all the different bits of data for us. And so it did take a little bit of work. I think the person spent maybe probably a week putting it all together. But it was just another one of those things. So we ended up with good QA data that we could test against, we could write our code against and everything like that. But we weren't putting in like PII data. So that was kind of our way around that whole conundrum, so to speak.
The other big data question that comes up with dedicated databases, which we didn't mention, we probably should have done, is the fact that data can be quite big, right? Like if I've got a terabyte database, it's unlikely I'm going to be putting that on my laptop to do some dev work. Do take a good look at cloning tools. Like there's an open source one called DBA Clone, part of the SQL Collective, and there's one from Redgate called SQL Clone, which you have to pay money for. But these sorts of tools are great. They use the same sort of virtualization techniques that Docker and containers do to create thin copies of the data in the same way that Docker containers create a thin copy of the operating system. And it allows you to kind of insanely quickly, like in a fraction of a second, spin up a local editable copy of a 64 terabyte database on a low performance VM, on a low performance laptop.
Absolutely. So I think we'll include some links to that as well. I have a whole bunch of notes. I need to make sure I keep track of all the links that we're going to include in this follow-up email. It's going to be quite the email. But I'm going to move back, and thank you very much, everyone, for joining us today. Sorry we ran out of time. That went a lot quicker than I anticipated. I thought it was a really good discussion. If you are interested in any future webinars, we have one coming up in 2 weeks where it's going to be Mark and Leanne, and they're going to be talking about the Octopus Deploy REST API and some best practices on how to use that. And I think they're going to provide examples. So again, thank you very much, everyone, for joining us, and have a great rest of your day. Thank you, Alex.
Thank you very much for having me, Bob.